I'm Vineeth. I work for Yahoo in Bangalore, and my presentation today is on managing changes on Yahoo's Hadoop infrastructure servers. A brief about me. I have been working for Yahoo since more than past 5 years. I work as a senior production engineer there for the GridOps team. I am responsible for maintaining and managing Hadoop infrastructure at Yahoo. So this is how the Hadoop stack at Yahoo looks like. You have the base HDFS, underlying storage. We have Yarn, HBase, Storm, and we have a lot of umbrella applications like Oozie, which is a workflow management, HCatalog, Hive, and a lot of tools for data movement, and underlying infrastructure like LDAP and Kerberos for managing the users, etc. Hadoop at Yahoo runs at a very huge scale. We kind of are around 45,000 to 46,000 machines running across multiple Hadoop clusters or grid. And for a platform like Hadoop at Yahoo, the sheer magnitude to which we serve to our different customers and to their different requirements, stability, reliability, and uptime are highly crucial. So we make around more than 15 to 20 changes every week to Hadoop application or the umbrella application, like package upgrades, configuration changes. We also make a lot of changes to the OS config, security pushes, again, package upgrades, config file management, and also to the underlying infrastructure like monitoring, logging, and application infrastructure. So one of the key objectives of GridOps team is to kind of manage these changes on this huge platform without taking a hit on the aforementioned traits like stability, reliability, and uptime. Because a lot of customers rely on us, and whatever change we make shouldn't really bring cause downtime or cause disruption to the service. So we have certain rules that we have set, which I'll be discussing in the next few slides on our rules or guidelines on to which we adhere to kind of make sure that we follow our practices to ensure that this platform is always up and running. So these are the rules. We strictly follow continuous delivery and DevOps practices. We need to ensure that every node out of those 46,000 nodes has the right config and package versions. A change any change should be pushed within a specific time period, and it should not be delayed, and it should be uniform across all the nodes. And any change that we make can be easily visualized, tracked, validated, monitored, and if necessary, rolled back. Although we are a roll forward, we follow the roll forward philosophy, we need to still have the ability to roll back changes on our scale. We need to ensure that the pipeline, which is our backbone, is feasible to support, to promote pushes across Hadoop in a staged fashion. Changes are smooth, there is a flow in the change, and there are no disruptions. And we have gates in place across these environments to reduce the impact of a bad change. So if there is a bad change, then the gate should kind of help prevent cause minimal impact to a specific environment and not cause outage across multiple environments. And all these changes, system, app, or any change, once reviewed and committed, should be automatically pushed with very less manual intervention. So in this presentation, we will discuss the automation, the philosophy, the practices that we as GridOps follow to achieve our key objective, that is to manage the system and application changes. We believe that these philosophies and practices can be followed by different SRE teams managing large-scale infrastructure across different companies, and that should kind of help them assist managing their infrastructure much better. So we'll quickly, during this presentation in the next few slides, we'll cover these following areas: the tools, how our pipeline looks like, and the pipeline in action, and how do we manage the packages and configs, and last but not the least, monitoring, which is very crucial, and how we tackle monitoring even in our continuous delivery and deployment model. So we'll start with tooling. Yahoo traditionally had been following DevOps practices since many years. So we had a lot of tools that were following certain philosophies and practices, although in those days they were not coined as DevOps philosophies. But for example, we had something called Yahoo CM Engine, which used to manage the configuration management for us. We used to do a lot of pushes via SSH from a jump host that had access to every machine out there. We had one-time setup scripts, one-time for managing configuration files that really don't change during the life cycle of a node, which we do via Kickstart. We recently, since the past few years, have moved to a more open source approach. We are heavily using Chef for managing a lot of OS stuff, underlying stuff. We have something called rolling upgrade, which we use to manage Hadoop and Hadoop core application upgrades. And we have something called component safe upgrade, which is used to manage which we use to manage the application or Hadoop umbrella applications. So Chef at Yahoo at grid scale, to really meet grid scale, we needed to ensure that it is consistent, scalable, and reliable. So any products or any tools that we use at grid, we need to ensure that those tools are really scalable to our needs. So this is how a basic pipeline looks like. Many of you have a CD pipeline looks like. So you would have sandbox onto your left and production onto your rightmost side. Changes from CI, from RE, which get certified, packages that get certified get landed in sandbox, and then they get staged there, and then you push it all the way right. Promotion gates are something like which act as barriers. They kind of help. They kind of make sure that a change is only restricted to a specific environment, and it doesn't make it all the way across multiple environments when you push it. A simple example of a promotion gate, for example, is an environment to a simple example could be an environment to a version mapping file. You can have a simple YAML file where you would have the environment name and the package versions mapped to it. Other examples could be, if you're heavily using Chef, you would have the Chef cookbook constraints mapped to an environment where an environment would have all the list of cookbooks and their versions that are hard-coded to be converged for that node in an environment. This is how the grid pipeline in action looks like. So we have around 20-odd clusters. So the same philosophy, we have each and every, the square boxes here are Hadoop clusters. Each and every Hadoop cluster is an environment by itself. And the oval-shaped boxes are components inside an environment. So we have something like data nodes, which is a component, resource manager, and node manager, and name nodes, which are individual components. So the leftmost one is sandbox, and we have sandbox research and production. And because, and we have a lot of different production environments. If you see, we have around 10 production environments, because we have different customers who have different needs, different properties, different business units for their different use cases. So we support multiple production environments for them. So the default promotion policy for a simple change, the default promotion policy, when I say promotion, it's how the change gets rolled over from one environment to the other environment, is 1, 2, 3, 4. So it goes to sandbox, and from there we pick a cluster in research. Research gets the change, and from research, production gets the change. Now, the characteristics that the grid pipeline has is we have more tighter control. So any change that we push, we ensure that the change is restricted to only that environment. so that a bad change has minimal impact. And the pipeline itself supports a continuous flow where there are no disruptions. And we also have the ability, the pipeline itself gives us a lot of flexibility. For example, because we support different customers, we just can't have one major version in the pipeline at any point of time. We support more than one major version at any point of time. So we need to have the ability to support multiple versions pushed to a specific component. For example, if we want to push a version to the data node, which is very specific to a specific production cluster, and none of the other data nodes shouldn't get that change, then the pipeline should kind of allow us to do that. Similarly, we should also have the ability to support multiple tiers where, as I said, we want to push a change only to a specific component but not to any other environments, only to a specific environment and not to any specific component in that environment. We should have the ability to do that. And also, we need to have the ability to support emergency rollouts. So default continuous delivery pipelines don't really have the concept of emergency rollouts. Emergency rollouts are something like a specific production cluster needs to have a change, and none of the other clusters in Sandbox or Research or other production clusters don't need to have a change. So via Swimline, the change directly goes to the intended cluster. So the pipeline should have the ability to support it. So how does promotion happen, and what's promotion? Promotion is a way how changes get pulled over from the successor in the pipeline from its predecessor. So a predecessor has the list of change versions, the application or the package versions that it's running successfully, and it's time to roll it out to the next environment in the pipeline. That's when we kind of promote it. So promotion can be based on either results or validations, where you push a change to an environment, you monitor it continuously, you do a lot of monitoring, you do a lot of validations like Jenkins jobs, etc. And based on the success rate, you kind of promote it to the next environment. Or promotion can be also based on metrics, where you don't, there is less manual intervention, there is continuous monitoring happening on your application metrics. And if the metrics are in a specific range, that's when you promote. If your metrics fall above or below your range, the promotion doesn't happen. For a pipeline like Grid and Hadoop Scale, we follow promotion based on results and validation and not necessarily on metrics, because each and every, our environments are heterogeneous. So each and every customer has his own use cases. So we follow the results and validation approach. So let's, in the next few slides, we'll kind of discuss few examples on how we manage config files, applications, OS and application configs. So what you see on the right-hand side is a simple monitoring config that needs to be pushed to every node. So that needs to be there on every node. So what happens is we kind of have this config in a specific Git repository. Every node pulls it from there, and before we make any change to the config file and push it to Git, we ensure that the config file syntax is automatically verified so that there are no errors. The change flows through the same CD pipeline that I showed you in the previous slides. So we make a change, we initiate the change on Sandbox, wait for measure results, and measure the success rate, and then push it to research and production. This works for, this is fine for complicated configs, but for simple configs like a monitoring config that you see on the right-hand side, which doesn't really cause any impact to your environment, which we call as a default config, we can follow a much relaxed approach. So what we do is we pick randomly a percentage of nodes across the Hadoop clusters, across multiple environments. We push that change, validate success, and then complete the change across all 100% of the nodes. The other example is a simple RPM package management. So we have a simple comma-separated file, or a simple file where we list out the list of packages, and there we can hard-code the package versions, the RPM versions, if we need a specific version to be installed, or else the latest will be installed. So here we have defined the package names, and then nodes pull this config, and then once they kind of find out if there is a new package name or if there is a specific version, new version available, the change gets automatically pulled by the node. So the same, this also follows the same CD pipeline. Promotion happens from pull from its predecessor. So whatever is there in the predecessor is kind of treated as a source of truth for the successor, and the change happens. Right, so the next change is very crucial, which we do a lot of changes. Application changes when compared to system changes are more frequent, and the rollout cycle for an application change is 2 times or 3 times more than a system change. For example, if you want to push a OS package or an OS RPM, it hardly takes 2 days for us to complete across 45,000 nodes. But if we are kind of pushing in Hadoop, if we are doing an Hadoop upgrade, we usually take around 10 days to kind of complete all our 20 clusters. So Yahoo has something called Yahoo Vineeth, which is Yahoo's installer, where the packages are defined. So what you see is a handoff from QE, where they have certified the list of the package name and the versions that they have tested, and they provide it in a timestamp serial. So we have a simple mapping file where the environment name is defined and the serial for that environment is defined. So this serial file looks like this. So it has the package name and the versions. So once we apply that serial to a specific environment and commit, and we do a push approach where nodes don't pull the config, unlike the previous 2 examples where config files were pulled by nodes. Application changes need to be more controlled. We need to know what's happening. So we push the change to those specific nodes via what we call as a one-click deploy, where we click a button and then the changes get pushed to each and every node. So in this case, how the promotion happens is once we push the change and the success is measured, the same timestamp serial gets updated to every other cluster in the YAML file. So a bit more detail on what happens in component safe upgrade or rolling upgrade on the application side. So we push a change via one-click deploy. We pick a node at any point of time. Only one node is, or only a percentage of set of nodes or one node is kind of picked up. We make the change and then run local validations on the node. We run health checks, and once those health checks are passed, and once we get a minimum, and once we ensure that the target rate or the number of nodes that are still available to serve traffic is still not below a certain percentage, that's when we go ahead with the next set of nodes. We fail fast. We fail if we make a change and then the change doesn't bring up the app back online, or the health checks are failing. We fail. We stop there, and we still have the limited percentage of nodes serving traffic, and the change is not really committed. So we can either roll back or fix the change and get back to normalcy. Once we complete the change, we don't really kind of celebrate success. We still run validations where which validation can be a synthetic transaction, like how an end user really acts. We mimic the end user by performing a synthetic transaction where just we submit a user job, which runs a lot of user-related different features. And once those validations are successful, that's when we kind of know that this deployment has been successful. Once a deploy for a specific component completes, there will be dependent downstream jobs which need to be also deployed. So that kind of automatically triggers the downstream deploys. How rolling upgrade works is it's more or less in the same lines. We proceed forward if there are no missing blocks and if the count between both the name nodes is matching. So this is what a process flow of whatever I described looks like. I'll skip it. Monitoring is very crucial for us. We can't really turn a blind eye on what's happening on the changes. We need to have a holistic view across the environment on how changes are getting pushed. So we have different, we monitor a lot of things from different areas. So as I said, we do validations, which are end user jobs. We have something called as a pipeline visualizer, which I'll kind of explain in the next few slides. We have grid auto break fix, where a node that is bad automatically goes into the auto break fix tool. It identifies the problem, acts on it, and puts back the node with the right configs. So this is a pipeline visualizer. So pipelines can go really complicated once you add a lot of triggers, a lot of downstream dependent jobs. You really need to know where the flow is disrupted. So this is how, this is a visual example. So here you see there's a job that turned red. So if it turns red, this specific job won't get triggered. So pipeline visualizer kind of gives a view of where there is a flow disruption. We have something called as conversion visualizer, where the nodes that are not properly converging to Chef, the nodes that are not really getting the right configs for more than a specific time period, we graph them. For example, here what you see is nodes that are failing to converge since the past 30 minutes. So the typical reasons could be nodes getting busy, they're getting unresponsive, network issues, disks getting read-only on that node, so nothing can run on that node, or code bugs in your recipes, so which really need to be fixed immediately. We also log a lot of change metrics. So any change that gets pushed is logged, and that log is immediately fed to Elasticsearch. So what you see here is a time series of how a change has been pushed and what's the success rate across environments and the time period it took for the change to be pushed. So these logs are immediately available for search and analysis. So if we drill down, we kind of can get to know what's the history of the changes that happened on that node and what's the success rate and failure rate. So it immediately acts as a feedback loop for every change that we kind of push. So here if you see, we pushed a change onto a node and the success rate was not really 100%. So if we drill down, I think this is a bit blurred, but the error is that slash partition got full on that node, and hence the RPM package upgrade didn't happen. So that kind of immediately acts as a feedback loop for us. And the last slide on validations. So any change that we make, we end the loop with completing the validation, which is an end-to-end job. So here we are running a validation on a HCatalog database where we made a change. So once we make a change, we create a temporary database on a HCatalog and we drop the database. We ensure that all those transactions are working and the result is successful. Validations need not just be end user Jenkins jobs, they can also be comparison jobs with the gold state or the pristine state, where certain nodes while you are doing the upgrade were not responsive and those nodes came back online after some time. So we need to ensure that those nodes don't get back into service immediately. So these jobs run continuously, compare the node with the pristine or the gold state, and identify that this node is out of compliance and this node has to be fixed immediately. And because we serve a lot of customers and a lot of downstream client applications, we notify our clients by something called as tags, which are just alias references to package versions, because package versions are really cryptic and people don't really remember them. So we update a tag saying this is the current version that just got upgraded on the node. So if you are a client and you're using the client libraries, just upgrade using this tag. So these are various validations that kind of can run as an on nodes. Right. To summarize, pipeline is the backbone. There is no pipeline, there is no push. Pipeline acts as your backbone to kind of push the change across multiple environments. The pipeline should have characteristics, and those characteristics should meet your business requirements. The pipeline should always maintain a continuous flow and should not cause service disruptions. Promotions should have gating criteria and promotion criteria. Changes can be, for us, changes are distinguished between system and application, and changes have a change life cycle. And monitoring, we follow a holistic approach in monitoring where we visualize every change, act on change if there is a problem, validate, and kind of get the feedback on how the change went through.